This is the demo for the smart farming. Smart farming is a project that we develop to monitor farms. So you're gonna get parameters of the weather and the soil, you're gonna send it to the cloud, analyze, process this data, and then we're gonna display. So basically here we're growing soybeans, and then we're getting parameters of the soil, okay? And then the project itself has two main stations. Is the weather station and the soil station. So first with the weather station we have a microcontroller here, which is the ESP32. And then we have three sensors. We have a smoke sensor, which measures smoke and gas as well. Then we have a humidity and temperature sensor. And then here we have a light sensor. This light sensor will be used to get how much light the crop is having. And then, here we have a battery as well that's powering this whole system. And then on the side here, we have the soil station. So the soil station uses the same microcontroller, ESP32. And then we have a few more sensors. First here we have the temperature sensor, which is getting data from the soybeans. And then beside that, we have a soil moisture sensor. And then we have the pH sensor. Here we have 4 pH solutions. We have water and 3 other different solutions. So we can test different pHs. And then together with the soil station, we also have a relay that is connected to the pump. And whenever the threshold of the humidity is crossed, this pump is going to be active and water the plants. All this data is transmitted to the Senet Gateway via LoRa. So this will have the LoRa boards in both stations. So here I'm using a lighter to put some gas on the sensor to trigger the fire alarm. And also here we have the probe of pH into a 9.18 pH solution. So we can also trigger the pH. Here we have our website, the smartfarming.site, farming, infer, nurture, and grow. The first thing we display in a website is our crop's health for the soybeans that we're planting right now. So it compares the temperature, the humidity, and the pH levels to the ideal ones. And by the light that the crop is receiving, we calculate how much time is left for the harvesting. So 49 to 64 days right now. The next thing that we show is the weather data. So we show the temperature, humidity, and light that the weather station is receiving. And also you can see that the smoke here is lit. It means that it was triggered. So if I come to my email right now and I update this, I have a fire alert that occurred. After that, I have the soil data. So I have soil temperature, soil humidity, soil pH, and also the pump status. So as I said, the pump status compared to the threshold and turns on or off the pump. Here I have the humidity sensor measuring the humidity of the soil. And then here I have the relay with the pump hooked up. So whenever it crosses the threshold, we see water coming out of the pump. So the next section is insights, which is actually divided in two parts. The first part is the change detection in pH. What it does is compares to a normal distribution, which right now has a mean of 6.8. And since the pH right now in my solution is 9.18, is giving a high value. This is done by a machine algorithm called CUSUM, which detects an edge. So if it goes to a high value or lower value, it triggers. The second part of the insight is the next crop prediction. So it's going to compare to my right now soil parameters and suggest which crop I should grow in the next sowing.